We're doing our third out of 4 transformations. This third one is called rotations. This is going to be dealing with the quadrants on the graph. You're going to need to know what those are and how you rotate. So let's go ahead and show you what this looks like today. So getting started, rotation. This is going to be a transformation that rotates, okay, the point around a single point, called the center of rotation. We are only going to be rotating around the origin. Listen, you can rotate around other points. We do not have time before the EOC to get that in and get the other stuff in. So we are only going to be rotating around the origin. That's the only point that we're going to be rotating around. Okay? That center of rotation for us is always going to be that origin. It's always going to be the origin. Now, when we do that, we're going to be moving around this using what's called the angle of rotation. We're going to move around this coordinate plane. In order to move around the coordinate plane, you have to know where the quadrants are and how you move. Guys, the positive one over here, this is called quadrant 1. Okay? This, however, is called quadrant 2. This is called quadrant 3. And this is called quadrant 4. How do you write 4 in Roman numerals, guys? IB. 1B, IB, however you want to say it. I knew what you meant. You had it right. Okay. Quadrants go counterclockwise. Guys, like this. I'm going to do it in highlighter so you can see. They go like this. Okay. That's the direction they go. They go counterclockwise. It says it right here, but I want you to see it very clearly. Your quadrants numbered. They're numbered in that order. They go around that way on the outside. Okay. Quadrants rotate counterclockwise. Oh, yeah. You don't have to tell me the quadrants. You just need to know where they are. You just have to be able to identify which one's which. Okay? It's not about naming it. It's about knowing where they are. Okay? That's a good question. No, you don't have to name them that way. Now, when you deal with this, you're going to be dealing with rotations in that counterclockwise motion. So think of it like a C. They go counterclockwise. Okay? The clock goes that way. We go this way for counterclockwise. That's what counterclockwise means, opposite of a clock. Okay? And so when you do this, you're going to be doing rotations. And these rotations for us, we're only going to stick with the basic rotations, are going to be based on 90 degrees. They're going to be based on 180 degrees. They're going to be based on 270 degrees and 360 degrees. Okay? The reason we do those is that will rotate it a full quadrant. It's going to move it from quadrant 1 to quadrant 2 if you rotate it 90 degrees. If you rotate that shape 180 degrees, it's going to move it 2 quadrants. If you do it 270, it's going to be 3 quadrants, and 360 is going to be 4. But let's talk about that. That means it's going to move 1 quadrant. Guys, look right here. This moved from up here in 2 to down here in 3. That's 1 quadrant. It moved 90 degrees. But do you see it also rotated when it did it? That's going to matter. Okay, 180 degrees means you're going to move 2 quadrants. 270 is going to mean you move 3 quadrants. Oh, what does 360 do? Goes back in a full circle. So where does it put you back at? Huh? I didn't hear what you said. What? Same spot. Put you right back where you started from. It's going to put you wherever quadrant you started from. If I started here and moved 1, 2, 3, 4, guess what? It's going to end up right where it started. So the same place it started. If they say 360, then the numbers are all the same. Nothing changes. If it says 360, it puts you right back where you began. Anybody ever say, oh, they did a 360 turn? That they changed their mind completely. They changed it 360 degrees. If they say that, 360 degrees actually puts you right back where you started. What's the exact opposite of where you started at? 180. 180 is actually the exact opposite. 360 puts you right back where you began. Okay, guys, so rotations are going to be a rigid motion. They don't change size. Rigid motion. They're not going to change the shape at all. They don't change sizes at all. The only one that's not rigid will be our last one, which we do on Friday. They are shown with a lowercase r. Okay? This first thing right here, the first number is going to be your angle of rotation. And then the second thing is going to be your center of rotation. But guys, what do we say? We're always going to rotate it around, at least in this class for now, the origin. We're always rotating around the origin. It makes things a little easier. You don't have to shift points and do all kinds. You just flip numbers. I'll show you. The formula is easy peasy, guys. You just have to learn the formulas. There's a set formula. It works every time, but you got to learn these. There's 3 of them. You got to know them. You don't need the 4th one because it ends up the same. The 4th one you don't need. You don't need one for 360. You need one for all 3 of these, and they're straightforward. You just got to learn them. Okay, guys. Anybody still writing before we get started? If you are, I'll wait. No? Okay, here we go. Let's get started on this. Here are 3 pictures that have been rotated. This one has been rotated 90 degrees. This one has been rotated 180 degrees. This one has been rotated 270 degrees. And we wouldn't show the last one because it would end up right back where it started from. 360 would end up right back where it started from. Now, there is a set rule for these rules. This is what they look like. If your point starts off at XY originally, like, let's pick one point to go with. Let's say A. So let's say A starts off originally as what ordered pair? That's 1, 2, and 1, 2, 3. The ordered pair is 2, 3 for A. To rotate it 90 degrees, you are going to rotate it by switching the 2 numbers. So now the Y is going to be in front and the X is going to be in back. And the Y is now going to be the opposite of whatever it was to begin with. So if it was positive, it's now negative. If it was negative, now it's positive. So do that to the A down here, guys. Switch them. Change the one that you put in front to the opposite of whatever it was. What's the new ordered pair going to be? Negative 3 what? 2. That's it. Negative 3, 2. You just did it. Okay? The second rule starts off the same way. You start off with that original point of x, y. We'll do A again. We'll call it 2, 3. We'll just use 1 point for now, just to show you the rules. We're literally just showing you the rules, guys. So if you start off with that, the new ones are going to be the exact same location. You still have X, you still have Y. But guys, these are both positive in this case, and these are both going to be flipped over completely. So basically all you're doing is making both of them the opposite of what they started with. Don't move the numbers, don't do anything. All you're doing is changing both the signs. Right? So my new point would be what? Negative 2, negative 3. Perfect. That's it. So my last one, x, y. Now it kind of makes sense when you start thinking about this one. This rotated 1. This is going to rotate 3. So you switch the numbers again. You still have the y in front. You have the x in the back, just like you did for the first one. But instead of changing the sign of the first one, now you change the sign of the second one. So if A starts off at 2, 3, if we're flipping them and changing the sign of the second one, what's it going to be? 3, negative 2. Perfect. No issues with the rules at all, guys. That was great. Usually I have people get that completely wrong the first time through. That's awesome. So that's the rules. We apply those rules one at a time. There are four problems. We have one of each type just to make sure you know how to do this. The last one is the easiest one. Here we go, guys. Let's get started. Oh wait, anybody still writing? I'm sorry. Not on this one? Okay, here we go. So the first one's going to rotate 90. When you see a rotation of 90, the very first thing I want you to do is write down the rule. If you're rotating 90, you're switching them, you're changing the sign of the first one. The easiest way to remember it is you switch, change the sign of the first one because it's the first rotation. Okay. So I wouldn't even look at the picture to start off with. I would take these numbers and I would go ahead and change them down here and do A prime, B prime, and C prime, and go ahead and change them down here You already have the ordered pairs listed at the top. You switch them, change the sign of the first one. So if I switch this, the 3 is now going to be in front, the 1's going to be in back, but what do I have to do if I make this the opposite of negative 3? It's now going to be what? Positive 3. Perfect. So for the second one, if you switch it, change the sign of the first one, what's it going to be? Not negative 1, 1, 1. Because if we switch them and change that sign from negative to positive, if I switch them, it'd be negative 1, 1, and then I got to change the sign of the first one. It would change from negative to a positive. For the next one, if I switch them, change the sign of the first one, what's it going to be? 2, 4. Okay, questions? Because I got a little bit of looking face. Yep. Take your time.
Why do you change the all?
I change it to the, because the formula says the opposite of whatever that variable is worth. So think of it like this. I'm going to show you how to write it out maybe, and it'll help you do this. So when you switch them, it switches to this, switches to negative 3, 1, and you got to change this to the opposite of whatever it is. And the opposite of negative 3 is 3, 1. Is that better when you see it like the double negative thing? That's really what it is a double negative. Yes?
I thought it would be negative.
No, you gotta switch. Oh wait, which one? This one? B? So let's switch them. So we switch these two. It'd be negative 1, 1, right? But we got to take the opposite of the first one. What is the opposite of negative 1? That's how it ends up at positive 1. Guys, ask. Thank you. These are the kind of questions. Thank you for asking. Anybody have any other concerns on that one? Okay, let's do the next one. Guys, what's the only thing you do on the next one? Don't change any signs. All you do is what? Switch them. That's it. All you do is switch them. So you're going to have the y over here and the x over here. That's all you do. No. I'm waiting for somebody to say no. That's not till the next one, guys. What do you do on this one? You don't switch them at all on this one. What do you do on this one? Both of them make them both negative. Thank you. That's not till the next one when you switch them again. This one doesn't switch. This one's just the opposite. So really all you're doing on these is changing every sign up here to the opposite sign of what it is. If it's negative now, it's going to be positive. If it's positive now, it's going to be negative. So when I look at this and I do my A prime, my B prime, and my C prime, what is the A going to be if I just change their signs? Negative 1, 3. Perfect. What's the next one? B. Negative 1, 1. What's the last one?
Negative 4, 2.
Perfect. Perfect. Just change the sign. That's it. Exactly right. So we need to graph these two before we go on to the next slide. So take a minute and graph these. We're going to start at this origin. You're going to go to the point 3, 1. That's A prime. We're going to go to the point 1, 1. That's my B prime. And you're going to want to go to the point 2, 4. And this is a really easy way to check your work and see if you did this correctly, guys. Because if you don't have the same shape rotated up, rotated one time, then you know it's not right. There it is. I rotated it one time counterclockwise and it turned up when I rotated it. That's perfect. For the next one, excuse me, the points are negative 1. Oh wait, let's mark my origin. So negative 1, 3. Negative 1, 3 is A prime. The second one's going to be negative 1, 1. That's my B prime. And then C is going to be negative 4, 2. There's my C prime. And did that rotate 2 quadrants from where it originally started? Yeah. So you got it. And it flipped 2 times. It rotated over 2 times. Goes the exact opposite direction of where it began. Okay, on those 2, yeah. Numbers are sometimes and sometimes not. You'll see we're going to do that practice test Monday. You'll see some of them do and some of them don't have them on there. And some of them you won't even have the grid space. They'll just give you the numbers and you'll have to, if you want to work it on the grid, because they'll ask you to graph it, they'll just have the blank grid. You might want to do it on your own paper so you can number it. You will get a sheet of paper that's like a booklet like you did for Algebra 1, and the back side will be all graph paper if you need it. And you can ask for as many of those as you need, guys. Okay, anybody on these before I rotate to the last thing? Okay, sorry, didn't mean to make a joke there. Okay, here we go, guys. I'm gonna do example 12 first. Why am I doing 12 first? Because, guys, listen to me. It's 360 degrees. That means it ends up exactly where it started. So your new points, A prime, B prime, and C prime, are gonna be the exact same points you started with. It's gonna be 1, -3, it's gonna be 1, -1, and it's gonna be 4, -2. There's no change. When it's 360, there's no change. No change at all. Okay, so to graph that, all you do is right next to the B, you put B prime. Right next to the A, you put A prime, and right next to C, you put C prime. There's no other, it's right on top of where it started. 360 means it went all the way around and came back to where it began. It's a big circle. Anybody on that one before we do our 270? Huh?
So we have 360, you don't change it?
There's no change when you do 360. It's basically like going around in a circle and you end up right back where you started. That's what 360 means. Yep. Yeah. Anybody else? Okay, here we go. So 270, the rule is switch them. So you still got the Y in front and the X in the back like the first one, but which one are you changing the sign for, the X or the Y? X. The X is the one you change the sign for. So when we're going through and doing these, A prime, B prime, and C prime, you've got to remember that you're going to be changing the sign for the one that you switch to the back. So if you switch them, the first one would be -3, 1, just switching them. And then you got to change the sign of the one in back, so your answer would be what? -1. Perfect. -3, -1. If you switch the next one, it'd be -1, 1. And then you got to change the sign of the one in back, so your new answer would be what? -1. What? I didn't hear it. I didn't say it was wrong. What was the second one? -1, -1. Perfect. Got that -1 there. Awesome. I just couldn't hear you. Okay. Last one. If you switch them, it'd be -2, 4. So when you change that sign, what's it going to be? -4. Perfect. Let's graph those. So see if it rotated at 3 places. If it rotated at 3, it should end up right here. Should end up in that quadrant right here. So let's see, from our origin, that's going to be -3, -1. That's A prime. Then it's going to be -1, -1. That's going to be B prime. And then -2, -4. There's our C prime. There's your little triangle rotated 3 times around. There we go. Okay, yes, please.
Let's say we put 4 and -2. We don't get the same answer. We'll just go on.
Say, hold on. What? I didn't understand what you asked me.
So let's say we put 4.
That would give you a completely different graph. Watch. If you put 4, -2, like when you're talking about if you use the same point if you didn't rotate it.
Yeah, I know if you put 4 and you put the 2.
Yeah, it's going to change where that point is completely. So let's say that I did that. I would end up with this A. I'll change colors just to do it on top of this. I'd end up with this A. I'd end up with this B. And then 4, -2 would be at 4 and -2. So I would now have a triangle that looks like this. And I would no longer have the right kind of triangle. Does that make sense? So it does matter. Okay? Anybody else? Okay, guys, let's get you started then on your assignment. Let me go ahead and get this cleared off. Save that.